In this video, we'll remember how we solved equations such as x squared plus 2x minus 3 equals 0 by graphing. We did that semester one, and we'll develop in this lesson an algebraic process to find the same answers to that equation, but without using a graphing calculator. So if we remember to solve this equation, we graphed y equals the left hand side of the equal sign, so y equals x squared plus 2x minus 3, and we also graph y equals to the right of the equal sign, in this case 0. So when we do that, the graph in blue here is a parabola, and as this curve right here, and the y equals 0 is nothing else but the x-axis, the collection of all the points for which the y coordinate is 0. And if we just click here on Desmos, Desmos will tell us what x values. Notice we are just solving for x, so x equals 1 or x equals -3. So if we replace any of those two values, -3 or 1, into the left hand side, the answer should be 0 for any of those. Well, we want to get those same two numbers, but without using a graphing calculator. There is a general process to do this, and what I'm going to do first is I'm going to show you how the equation, the general quadratic equation, is derived. Please don't get lost in the details. It's only going to be how to get to that equation, and you will see that only once. And from that point on, we will replace the values each time, so it's not going to be this hard. So everything starts with a quadratic equation such as this one right here, where a is the number that multiplies the x squared, b is the number that multiplies the x, and c is the constant. So if we subtract c from both sides, we get the second step. If we divide each side by a, we get this third line right here. If we add b divided by 2a raised to the second power to both sides, so this term right here, to the left and to the right, we get that equation. Then if we factor the trinomial on the left, this trinomial, and for if anybody's curious, I can show you how you do that. This will be the square of a binomial. On the right hand side, this has been just changed, the order, but it doesn't, the signs have not changed. So b divided by 2a to the second power is still positive, and the other one is still negative. And over here, we are just adding those two fractions. Once again, I don't want you guys to get into the details, but I wanted to show you that there is a way to derive the formula. The important thing to remember is at the bottom, and we'll use that formula given the values of a, b, and c to find the answers or solutions to the equation at the top. So let's see how that works on my Desmos I have prepared right here. So in general, when you're solving this type of equation, yes, graphically, you will graph y equals to the left and y equals to the right. But basically, this is the formula that we developed, and it'll have two answers. When you plug in those values, in this case, a equals 1, b equals 2, and c equals -3. So if you replace those values here, you will get one answer, x equals 1, and the other answer happens when you change the plus in the middle by a minus. So in that case, you will get x equals -3. And those are the two values here. Please remember that those 2 points have special names. Those are the x-intercepts of the quadratic function. And I just want to show you here what happens, because of course the parabola is not always going to look like this. So I want you to keep in mind sometimes the vertex is there is a vertex below the x-axis, but what if we change this? Imagine we are changing this to 1, So, well, mm, I should have that y equals 1, but I don't think it's changing. So, for some reason, oh, maybe I need to graph it, right? So, I didn't want to have this highlighted here, but this one down here. So, when we're graphing those two, and I change that to 1, now the vertex is right on the x-axis. So that point, I got it here. Okay, so that point has only one x-intercept. So you will have quadratic equations for which there is only one solution, x equals -1 in this case. You will have, like I showed you before, equations where you have more than one solution, like in this case. I got those solutions highlighted here. So we can, one solution is going to be x equals 1, the other solution is going to be x equals -3. But of course, what if we keep moving that parabola upward? Like imagine that this is not even 1, like we said before. So in that case, the vertex and the x-intercepts are all the same. So the solution to the equation will be just x equals -1. And if we keep moving that parabola upwards, let's say this number here is 2, now we see that the parabola does not intersect the x-axis. So the solutions to that equation will be non-real. I want you to notice that the radicand, that means the quantity under the radical, the b squared minus 4ac in this particular case is negative. So when you take the square root of a negative, hopefully, guys, that will remind you about the lesson that we just covered, where we had imaginary numbers. So when does that happen? When you actually do not have x-intercepts, all right? But if you were to have, if we went back to that one right there, there is one x-intercept, and that happens exactly when the that number b squared minus 4ac is 0, because then in that case, you will only have one answer. This is going to be 0, and it doesn't matter if you add that number or subtract that number, you will get the same answer. So the answer in this case will be -1. So because this number and the radical or the radicand determines how many solutions and what kind of solutions the equation has, it is called the discriminant, and you will see that in the lesson. And of course, you can always refer to the book, but that's basically what is going on. And let's see if we can get some practice on that, mm, from IXL. Thanks so much, and please keep trying hard.